Hello everyone and welcome to this Nordic Tech webinar. Today's webinar is named Say Hello to Thingy 53, the prototyping platform for embedded ML. My name is Robin M. Saltness. I am a product marketing engineer here at Nordic Semiconductor, and I'll be handling this presentation for you today. So we'll start with a hardware overview over the most important components of the Thingy 53, mainly the nRF5340 SoC, the nRF21540 RFM, the MPN 1100 PMIC, and we'll go through all the sensors of the Thingy. Then we'll do a overview over the new apps that we released together with the Thingy 53, and in the end we'll do a live demo before we start the Q&A. And here it is. This is a view of the outer front casing and the front of the PCB mounted in the back casing. This is the two parts in the orientation as they would be if they were assembled together. So you can see that the hole in the thing has been replaced by a clear plastic eye or light guide TM in the same location to make the LED able to shine through and also the color and light sensor to look out through. And this keeps the same shape and visual appearance as all the other thingies, even though we have made a complete redesign of the casing. And you can also see that there's a big circle in the middle on the outside casing, and this is where you can push to operate one of the internal push buttons through the casing. You can also see that we have added a flap at the bottom that opens up to allow access to the on-off switch and connectors on the bottom. And this is a nice quality of life improvement over previous versions of the Thingy. And I'll also show you a little video of how this comes, how this disassembles if you wish to open up your Thingy 53. So this is a CAD model, but all other pictures in this presentation is actual pictures of the Thingy. Are actual pictures of the Thingy. So, what is the Nordic Thingy 53? Well, the Nordic Thingy 53 is a prototyping platform especially made for embedded ML and edge computing. It features the nRF5340 SoC as its main processor. It has also the nRF21540 RFM as an optional front-end module for a range extension. And all battery charging and power delivery is also handled by a Nordic device, namely the NPM 1100 PMIC. As you expect from a Nordic short-range device, this is a multi-protocol wireless connectivity device based on the 5340 SoC. It has Bluetooth LE, Bluetooth Mesh, it has Thread that makes it able to be used to create products for the new Matter standard. It also supports Zigbee, NFC, and all the less common protocols. It's fully self-contained, means that it has an internal battery, and it has a wide variety of sensors and interfaces, which means you don't need to add anything to use this as a prototyping platform. The only thing you need to do is write your firmware. And when it comes to writing firmware, it is fully supported by the NRF Connect SDK from version 2 and up. So one of the big upgrades of the Thingy 53 is the improved accessibility of the external ports and this on-off switch. So the casing now has a flap that you can open to access most of the connectors and the on-off switch without removing any part of the casing. We have changed out the horrible USB micro B port with a new and crisp USB Type-C, which is used for charging the battery, obviously, but also programming via MCU boot. Then we have added a completely new connector, a 4-pin JST, which is compatible with accessories using the quick slash stemma slash groove. There's different names for this hardware protocol that third-party manufacturers used to create hardware accessories that can easily be integrated with the thingy. For instance, there's a sensor you want, or if there's some external hardware that you want the thingy to have and to use with it, it's now easily just plug it in and you have a connector for it without soldering to test points and inside of the thingy. We have the same programming ports as the Thingy 52 and the Thingy 91, which enables you to use a 10-pin debugger, for instance, a dedicated JLink programmer, or if you have a dev kit, you can just use the 10-pin out for the debugger that's on the dev kit. The thing itself does not have a dedicated JLink chip. We also have a new port to go with a debug and current measurement board that comes in the package with the Thingy 53, and that is the slot that you can see right below the power switch there. So this is the front and back side of the PCB in the Thingy 53. This is a list of all the main components on that PCB. So you can see all the sensors. We have the color and light sensor up in the top left hand corner, right next to the Nordic logo there with the RGB LED. So these two are obviously dependent on that light guide, the clear plastic eye in the casing. Then right below it you have the environmental sensor in the little cutout piece of the PCB there. It measures temperature, humidity, air pressure, and gas. Then you have a accelerometric gyroscope combo and a magnetometer. These two together makes out what we call a inertial measurement unit. In addition to this, we also have a low power accelerometer, which supports wake on event. So you can create low power applications, only waking up the 5340 when there's actual accelerometer data to process. Same goes with the little MEMS microphone. This is a very good microphone. It also has a wake on event, so you only wake up the device when there's audio to process. And it's actually the same microphone that is on the NRF 5340 audio dev kit. So it's a very good microphone in regards to its size. For other HMI, we have two buttons. You have the one button that's accessible by just clicking on the casing, and then right next to it there's a smaller button that you have to open the casing to access. And this is the button you would use to put the thing into boot mode. And in addition to this, we have the RGB LED already mentioned, and we have a buzzer. And you can see all the external connectors are on the bottom of the board there. We've already talked about them a little bit. In addition, we have the NFC antenna connector internally, which comes with a pre-attached antenna, and we have an internal battery connector that comes with a pre-attached battery. And then you have two SWF RF ports for direct RF measurements, one for the antenna that goes straight to the NRF 5340, and one for the antenna that is connected to the output on the NRF 21540 RFM. So we can measure both the antenna, we can take RF measurements on both of the antennas on separate antenna ports. So for completeness, I've added these two images of the little debug and current measurement boards that come in the package with the Thingy 53. Not boards, board. There's only one in the package. This is the front and back side, so two pictures. So it connects to that little slot under the on-off button, and it allows you to measure current on 4 different places on the Thingy 53. So you can measure the current used only by the NRF 5340 SoC itself, or by a different header, you can measure the current consumed by the NPM 1100 PMIC, which means the current used by the whole system, because the PMIC supplies the whole system, right? Then you have one for the current consumed by the NRF 21540 RFM only. And the last header is for measuring the current that is drawn through the 4-pin DST connector. So effectively, you're measuring the current drawn by any external hardware that's connected to the thingy. And then we have also added a 20-pin debugger connector for those who wanted to use a 20-pin debugger with their Thingy 53. So let's get into some specifics of the components on the Thingy 53. This is the NRF5340 SoC. Some of you might know this from before. It is our flagship dual-core wireless SoC. It has 2 processor cores, ARM Cortex M33 cores, both of them. The main application processor runs at up to 120 megahertz, 128 megahertz. It is extremely high performance. It has a load of flash and RAM, a mega flash, and 512 kilobytes of RAM. So you can run any application on this without any fear of running out of processing power or storage space. In addition to this extremely powerful processing core, it also has an ultra efficient low power network processor. This is fully programmable. It runs at a very efficient 64 megahertz. It has less flash and RAM because it's intended for the network stack, but it is fully programmable, so you can put whatever you want on it. But we recommend you use it for our multi-protocol 2.4 gigahertz radio protocol stack. And this is what gives it the ability to run Bluetooth LE, Bluetooth Mesh, Thread, Zigbee, NFC, and all that good stuff. And Thread and Bluetooth LE together, which enables it to be used for developing Matter products. Then you have the range extender, the NRF21540 RF front-end module. It is controlled by either direct pin control or the built-in SPI interface. So the default setting for the Thingy 53 out of the box is using the antenna that bypasses the NRF21540. So if you want to use it, you have to enable this manually by the use of the RF switch. And then you can gain access to the up to 20 dBm output power plus and minus 100 dBm RX sensitivity that it offers. And so this is the block diagram for the NRF RFM. You can see it's basically two big souped up amplifiers for receiving and transmitting. Then we have the power management, which is handled by the NPM 1100 PMIC. You can see with its 400 milliamp charger and 150 milliamp max capacity regulated voltage output, it handles the power supply to both the NRF5340, the NRF21540, and all the sensors. And it's also responsible for charging the integrated battery. And as we can see from this slide, the power switch is not between the battery and the NPM 1100 PMIC, and that means that this thingy can actually be charged while it's powered off. That's another quality of life improvement from the Thingy 52. And as you probably understand by now, this is the complete block diagram for the Thingy 53. And some other interesting things to note is the 4 gray boxes, which says current measurement, which is where you'll be tapping in when you use the current measurement pins on the external debug and current measurement board. You can also see that the RF switches between transmitting on antenna 2 and using the NRF21540 with antenna 1, as I mentioned earlier. So for the sensor hardware, this is the product numbers for all the different sensors that we've bought in from different suppliers. So you can see Bosch is heavily in here with its BME 688 temperature, humidity, pressure, and gas sensor. I visited their booths at Embedded World just 2 weeks ago, and they had a really cool demo of this sensor using the gas measuring to put it over different drinks and judging if the drink was non-alcoholic or not, which was really cool. And that can be used for either if you wish to know, for either way, if you're concerned with not getting alcohol or with getting alcohol, you can use this sensor for both. Then we have the Bosch BMI 270, which is the inertial measurement unit, or the gyroscope and accelerometer combo. And then you have the Bosch BMM 150, which is the magnetometer. And from analog devices, we got the ultra low power accelerometer with wake on sleep, ADXL 362. And then ROM Semiconductor supplied us with its BH1749 color and light sensor that peeks out through the light guide. And then we have the Vesper MEMS VM3011 digital MEMS microphone, which is the same microphone that's on the NRF5340 audio DK, which is a super high quality microphone for being such a tiny device. Then we have the two new apps that we have launched together with the Thingy 53. We have the NRF Edge Impulse app, and we have the NRF Programmer app. So the NRF Edge Impulse app is developed in cooperation with Edge Impulse, and it allows the Thingy in 53 to seamlessly integrate with Edge Impulse Studio, which is in a much more streamlined way than any other device currently on their platform. And then we have the NRF Programmer app, which is a completely new app for doing device firmware updates on the Thingy 53, which also take this to a whole new level of simplicity. But let me first go through the NRF Edge Impulse app. So this is the big new thing with the Thingy 53, and it's because of the superior processing capabilities of the dual-core NRF5340 SoC. It allows it to support embedded machine learning. So the firmware needed to use the Thingy 53 app, or the NRF Edge Impulse app with the Thingy 53, is the firmware that comes preloaded with every Thingy 53 out of the box. It's shipped with this. And it makes it really simple to make ML models, both when collecting data and downloading trained models from the cloud and into your Thingy 53. This makes the Thingy 53 the ideal starting point for a rapid embedded ML prototyping. And here's why. The Thingy 53 specific app, the NRF Edge Impulse app, it makes it integrating with Edge Impulse so seamless experience. You don't have to first collect the data sample, then store them somewhere, then upload them to Edge Impulse Studio as multiple separate tasks. Once you have started sampling, you use your phone as a GUI to sample the sensors on the Thingy 53. And once that sampling is complete, it is automatically transferred to the phone from the Thingy, of course, and then the phone's uploaded to the Edge Impulse cloud. So the data is already in the cloud almost as soon as it's done sampling. And it's ready in the cloud for use to build your ML model. And then when you're finished building your ML model in the cloud, and you want to deploy your ML model to the Thingy 53 for inferencing, it's already there. It's already in your library on the phone on the drop-down menu, and you simply have to click build and deploy, and then it's transferred over to the Thingy, and you're ready to start inferencing. And when you want to inference, you have the phone as a GUI to read out the inferencing results. And to make this even better, there's a lot of low power components in the Thingy 53, like the low power accelerometer and the MEMS microphone that both has wake on event capabilities. So you can create extremely low power ML solutions that actually run the inferencing only when there's input to process. So you can save a lot of battery life. So this is the wheel of rapid ML prototyping. So it starts with sampling any sensor data. All of the sensors on the Thingy53 is supported by the app, and also some combinations of sensors are supported by the app. And then you gather the data from the thingy completely untethered. It goes via Bluetooth LE to the phone and up to the cloud. In the cloud, the only step you have to go through in the cloud is to build your ML model. You do this in Edge Simple Studio, and in my opinion, it is a really, really user-friendly environment to be in Edge Simple Studio. I made my own ML model first time in less than an hour, which I think says a lot. Then a fully trained ML model can be transferred over Bluetooth LE wirelessly right into the Thingy53 from the NRF Edge Impulse app. You don't have to download it from your account to the phone. It's already in the app when it's because you're logged in the app and your account, right? Then you inferencing, you do it directly on the Thingy53. All of the inferencing runs on the Thingy53 hardware. But to have a GUI for reading out the inferencing results, you use your phone simply as a readout. So all the processing is done on the NR5340 SoC, but you read it out on your phone's screen. So the results are sent over Bluetooth LE, but not the actual sensor data when you're doing inferencing. And then you can repeat all these steps again and again until you have perfected your ML model and made it just the way you want it. So let's do a little demo of this. So this is the Thingy53, or this is my desktop, but this is the Thingy53. And this is how it comes out of the box, or rather this is the box. Inside the box we have the Nordic Thingy53, and we also have a little debug and current measurement board. We also have a nice little quick start guide. So, power on the Thingy53, you just simply open the flap, no need to dismantle the entire casing. Turn it on, and you see it come to life. Then, to use it, we open up the NRF Edge Impulse app. Let's see here. And you can see it shows up as a device named Edge Impulse. One click to connect, and we can go into the device and we can look at all the different sensors that it supports sampling on, which is all the sensors on the Thingy53, and you can see all the max sample lengths and the frequencies that it supports sampling at. And you can also see that there's combinations of sensors, so the light and environmental, the light and inertial, the environmental and inertial, and all three of them at the same time. So, and the Thingy53 Edge Impulse firmware actually comes with an ML model pre-installed. So if we go directly to the inferencing tab and start inferencing, we can see that the Thingy53 is laying idle on my desk, and that's what it's reporting. Then I can do a little snake motion, which makes it give a good, it reports a snake, which is this little motion. Then you have the up down, which also, this is a continuous motion tracking sample, so it just recognizes all the motions that I'm doing with the thingy. And then to the end we have the little wave. So you can see that it recognizes my wave. And as it inferences, it blinks blue. And I stop inferencing, and the thing actually reboots. If I want to add any more samples to this project, I just go to the data acquisition tab and I click plus. And then I give the sample I want to sample, or the data I want to sample, a label. And this corresponds to the inferencing result. So if I, for instance, want to make a speech recognition ML model of me saying different words, I can go hello world and name it that. And then I select my sensor, which is the microphone, of course. And then I select for how long I want it to be. I don't need that many seconds to say hello world, maybe less than 4 even. Then I click on start sampling and I say hello world. And as you can see, it has sampled, and now the sampling is complete, and it's uploading that sample audio up to the cloud. And if I go into my Edge Impulse Studio account online now, I can immediately see and use this sample in my ML model. That's how simple sampling new data is. And if I have already built my model and I want to deploy it to the Thingy 53, it's really easy. I just change which project I want to go. And my first project, I just named project name. It is a different version of the continuous motion recognition. So if I want to deploy this sample to my Thingy 53, oops, it's disconnected. If I want to deploy this sample to my Thingy 53, I simply go to the deployment tab. Let's see here. Let's reconnect. Oops. If I want to change out this sample with my own sample, I go to the deployment tab and then I click build. And you can see it's already uploading the data or to the Thingy 53. So this is uploading the sample, the ML model, to the Thingy 53. And this is how fast it goes. Now this is quite a simple motion recognition sample. I didn't take that many data points when making it. But my experience is that uploading new ML model is quite fast. And this is a live demo, so it is not in any way sped up. This is how fast it is. Then we're confirming and applying the update. And we will see that the Thingy 53 restarts by flashing its LED in different colors. And then it's completed, which will happen in about 30 seconds. There you saw the Thingy 53 restarted. And then the ML model update is successfully completed. So we might have to reconnect. And after reconnecting, we can sample this. And as you can see, the results have gotten new names based on what I put in when I made this model. So this model isn't perfect because it's made by me, but it's supposed to recognize circle movements, which it also thinks of idle as, and it also should recognize me conducting an orchestra, which it kind of does. Just a simple little demo to show you how easy it is to update the firmware. So that was it for the NRF Edge Impulse demo. Then we'll go back to the presentation, and I will tell you a little bit more about the NRF Programmer app. So the NRF Programmer app is a new app for over-the-air DFU on the Thingy 53. It's called the NRF Programmer for Thingy 53, I think, in the app stores now. And you can see that this guy is very happy, the guy in the picture, because he updated the firmware on his Thingy 53 based prototype out in the field, and he didn't have to drag his like big workstation PC out and connect it via USB cable and use a lot of different PC tools to update the firmware. No, he simply brought his phone, and then he used the programmer app to just do a DFU, and he has mounted this thingy up in the factory ceiling of a big warehouse, and he's scared of heights. So he's so happy because he didn't have to go up in a ladder or a lift or anything. He can just stand there on the factory floor and update over the air. So for now, the NRF programmer app works with the pre-compiled Thingy 53 firmware samples from the NRF Connect SDK. In the future, we plan to support this for also custom firmware and logging into your NRF Connect account with actually through VS Code and have this as a much more streamlined way of updating your custom firmware. But the natively supported firmware today is these samples. We have the NRF Edge Impulse firmware, of course, which is compatible with the app. Then we have the Light Button Service, the LBS sample, that's compatible with the NRF Blinky app. Then we have a peripheral UART sample that is compatible with the UART profile in the NRF Toolbox mobile app. Then you have all the mesh apps or the mesh sample that are compatible with the mesh app. It's the mesh light, the switch, the fixture, and the sensor. And then you have the Matter Waiter Station app sample application, which we showed on CES 2022. We have a small video of that on our YouTube channel that you can go look at. Then we have a Zigbee weather station, which is the same application but using Zigbee for communication. And then we have the NRF machine learning application with this, which is compatible with Edge Impulse's data forwarder. So we have a little bit time to spare, so I think I'll also do a small little demo of how easy it is to update the firmware with this app. So let's go back to my desktop, my physical desktop, and open the NRF programmer for Thingy 53. Here you can see all the different samples, and let's do the Blinky. Download the Blinky sample, install it to not my TV. Might have to reboot the thing again. There it is. There's a thingy. And we're now uploading new firmware to the Thingy 53 over Bluetooth LE. And again, this isn't sped up in any way because this is a live demo. This is how fast it is. So it successfully applied the update. It takes some seconds for it to be completely done. As you can see by this error message or this warning. But now you can see it's blinking. And if I go into the Blinky app, I connect to the thing, I can use this to change the color of the blinking light. So now it blinks yellow and green, and if I click the button in the app, it will switch to blue and white. And you can also see that the app has a Norwegian text saying inactive, which means inactive. And if I push the button on the thingy, it becomes pushed down according to the app. also in Norwegian. So that's how easy it is to update the firmware on the Thingy 53 using the NRF programmer app. So for developing custom firmware on the NRF Connect SDK for the Thingy 53, you would use the NRF Connect SDK. For making custom firmware, the NRF Connect SDK version 2.0.0 and later is the supported SDK. The Thingy 53 will be included in the NRF Connect Fundamentals course. The team is working on this, but this will also be a very nice resource to learn about NRF Connect SDK with the Thingy as a basis. So the SDK also has full hardware driver support for all the sensors on the Thingy 53. It also have many existing compatible firmware samples, and one of the things that will be included in the course is that it will show you how to take a sample that isn't natively supported by the, for instance, programmer app and make it compatible with the Thingy 53. And when you have made your compatible sample, you have multiple options to flash your firmware to the Thingy 53, either with an external debugger, for instance, a dedicated J-Link device, or through a Nordic Dev Kit. Then you have the MCU boot through USB option, or you have the OTA DFU option, either through the NRF Connect for mobile app if you develop your custom firmware now. So to summarize, the Thingy 53 has the processing power for edge computing and embedded ML. It has new connector for external hardware if you wish to add anything. Improved accessibility for the power button and all those connectors. It comes with 2 completely new apps, and it's fully supported in the NRF Connect SDK. And the picture you can see is all the things that comes in the box with a Thingy 53. Then we'll see if you had any questions for me, and indeed it looks like you have. So the first question is about the availability of the presentation, I guess the slides. I will publish the slides along with the video on demand of this webinar, so it will be ready in a couple of days at webinars.nordicsemi.com, and I believe you also will receive an email when this is available. Then there's a question about Edge Impulse and if it's free to use. Yes, Edge Impulse has what they call a developer tier, which is completely free to use. It supports an unlimited number of projects with up to 20 minutes of compute time per job, which is it's more than enough for ML, for simple embedded ML projects. And you can also have 4 gigabytes or 4 hours of sensor data stored on your account with the free tier. It's only the most biggest enterprise solutions that will need their enterprise package, I think. How big of a battery do I need to use the ML functionality on the Thingy 53? So the Thingy 53 comes with an internal 1350 milliamp hours battery, and I don't see any reason why you would want to switch that out. How long of a battery life you will get with that highly depends on your use case, but I think that battery should last you a good while with most reasonable ML use cases for the Thingy 53. Then we also have a question about the if we provide API libraries for the sensors. For instance, the IMU or the environmental sensor. It kind of depends what you mean by an API library. We have full support with the hardware drivers for all the sensors in the NRF Connect SDK, which means that you can build your own firmware and you don't need to write your own drivers or import drivers from the manufacturers because they're already implemented in the NRF Connect SDK, which also makes them implemented in Zephyr. But if you're thinking of an API library like the ones with the Thingy 52, where you simply write your communication app or applet that accesses the sensors directly over Bluetooth, we currently don't have that solution for the Thingy 53. Then the Thingy 52 probably would be a more suitable developing tool for you if that's what you want. Why is the sensor disconnecting sometimes? I guess it's the thingy that disconnected. So it disconnects on resets sometimes, but most of the times I was just double checking that it was still connected, so we didn't waste time if it had spuriously disconnected. But most of the times it was connected. Is Edge Impulse also available for Thingy 52? No, it is not. And the Thingy 52 isn't enabled for embedded ML, and that's simply because it doesn't have the same storage or processing capabilities that we have in the Thingy 53 because it uses a smaller NR52 series SoC, the NR52832, which was the first SoC that we launched in the 52 series. So it's starting to get seasoned. Can you have a model with multiple sensors, such as accelerometer and microphone, to take advantage of or to take an ML decision? The specific combination accelerator and microphone is not supported by the Edge Impulse app for data collection, and this is because when using the app, it gathers all the inputs as one data point. So I don't think we have and when you use the microphone, it actually uploads the microphone, the audio data to Edge Impulse. So I think simply we don't have made any efforts to make a data type that supports both accelerometer information and audio information at the same time. But I'm sure that if you try, you could make a ML model that uses both data types, but it will include some more manual work on the Edge Impulse studio side. I am not an expert on that, but the Edge Impulse have a very good documentation for all their tools. So that's worth having a look at if you're interested. And then there's two question that wants that asks about the NRF programmer app and if it works with older NRF52 series or historical NRF5 SDK. And the answer to this is no for both the questions. The NRF programmer, which is now called NRF programmer for Thingy 53 in the app stores, it's currently only supports the Thingy 53, and I'm not really sure what's planned for this app in the future. There's been some back and forth, and yeah, and the decisions are roadmap information, which we don't share publicly, anyways. So that's the answer to that question. And for the NR5 SDK, there's a definite no that it won't be supported either. NR5 SDK is in what we call maintenance mode. So new functionality won't be added. We will just continue to support what's already supported. When should custom firmware DFU support be available? Well, it's kind of already available. You will just have to use the NRF Connect for mobile or MCU Manager in NRF Toolbox, and then you can do DFU on your custom firmware. But it demands that you have created a DFU compatible firmware image and somehow transferred that to your mobile device that you used to do the DFU with. So it is a little bit of a more of a hassle than it in the future hopefully will be with the NRF programmer, which we want to make a cloud-based, completely automated system. Do we have any samples to utilize the NFC capabilities? Yes and no. And there is no compiled firmware image in the NRF programmer app that shows off the NFC capabilities, to my knowledge. But we have NFC samples in NRF Connect SDK, and when it's ready, the NRF Connect SDK fundamentals course will show you how to make samples compatible with the Thingy 53, and then you could take one of the multi-purpose or one of the standard NFC samples in NRF Connect SDK and make it compatible with the Thingy 53. And then you can also make it compatible with DFU and do a DFU firmware update to the Thingy 53 and make it NFC device. So we still have room for more questions. I am looking through the chat just to see if there's someone who's placed a question in there. Can you give us a quick comparison with the Thingy 91? The main difference between the Thingy 91 and the Thingy 53 is that the 91 is a cellular device and the Thingy 53 is a Bluetooth and similar protocols device. So the Thingy 91 has its own internet connection. That opens up a different range of capabilities, but it gives you a cost in the power efficiency. Other than that, the Thingy 91 also has slightly different sensors and not all of the it's not supported by the new apps, of course. see. Can the external 4-pin JST connector connect with other Groove-compatible sensors for embedded ML? Yes, it is Groove compatible. Now I'm not completely sure which one of these standard needed connector. No, I even forgot what it's called. The physical connectors are slightly different. It's slightly bigger for one of these standards, so it needs yeah, it needs a physical thing in between to make him completely compatible, because Thingy uses a smaller connector than what's on one of these, but it's compatible in the sense that it uses the same pins for the same signals. So yes, it's compatible with Groove. Can multiple Thingy 53s be meshed? Yes. We have all the mesh sensors, and if you want to use Bluetooth mesh for the ML capability, or for the ML capabilities, you probably also could mesh them and have a network of ML sensors, but that would require a little bit more work on the firmware side to make a firmware that supports both mesh, Bluetooth mesh, or other meshing protocols like Thread, and then also use ML to decide what data to send to each other. Can you recognize more complicated movements like dancing steps, consisting of 3 types of move, let's say snake, circle, and something else? I think that how complicated the models, or how complicated the movements you can recognize, is dependent on how much effort you put into making the ML model itself. So the Thingy supports longer sample lengths for the accelerometer than just the 10 seconds or the 2 seconds or whatever you want to use. So I think you can have really complicated movements if you spend a lot of time optimizing your ML model and putting in a lot of data for the sensor inputs that would want to yeah, that you would like the ML model to recognize. Can we expect an Edge Impulse app support for NRF5340 development kit? So the NRF5340 development kit is already supported by Edge Impulse, but not through the app. And this is because the NRF5340 DK doesn't have integrated sensors in it, which is kind of the advantage of the Thingy. So depending on which sensor board or which sensors you add onto it, your interface with the Edge Impulse would have to change a little bit, right? So we kind of can't make an app for it because we can't possibly make it compatible with any or all sensors that you might add to the NRF5340 DK to use it with Edge Impulse. Um, are there any license costs for using the model in a commercial product? I'm not completely sure, as this is something Edge Impulse would have to elaborate upon. I hope we can have a partner webinar with Edge Impulse in the future, and then that would be a relevant question to ask them. Then I think we'll do the final question, if there's not more questions after I answer this. Can the Thingy 53 communicate with a Raspberry Pi using Bluetooth? And that's the beauty of Bluetooth. It is kind of agnostic to which device connects and communicates with which device. So you should absolutely be able to create a firmware for the thingy that sends whatever data you want to do to send to a Raspberry Pi, and the same the other way around. You should be able to send whatever data you want with a Raspberry Pi to a thingy, as long as you have created compatible firmware images to support receiving that data. So thanks again for watching and have a great day.